So just a reminder, you will eventually have to memorize that unit circle. So right now you're probably using the one in your notes or like copied the one in your notes for the top of this page, but eventually you need to have it memorized. Just like a quick way to remember it. It's inside 3, 2, 1, outside 1, 2, 3. So the inside starting with goes down by 1 and the outside goes up by 1. Everything has a denominator of 2. So they're all over 2. And all of them are square rooted on the top except for 1 because the square root of 1 is just 1. So we just leave that square root off. In terms of the degrees, it's 30, 45, 60. They just go in order from smallest to biggest. And fractions, that's pi over 6, pi over 4, pi over 3. They go in order from smallest to biggest too, but sometimes that confuses kids. Like they think 3 is smaller than 6. But pi over 3 is a bigger portion of a fraction than pi over 6. So pi over 6 is the smallest, pi over 4, then pi over 3. All right, so just work on memorizing that. Eventually,
I'm stuck out, so.
oh, okay. Eventually, you're going to have to fill that out on your own. Like on your actual test, which is next week, or quiz I should call it because it's not really a test. The first part is going to be, here's a blank unit circle. Fill it in. And then you're going to turn that into me. The second part, I'll give you a completed unit circle, and you'll do the second part of the test. Because the worst thing that you could do is have the wrong unit circle and then do the whole test with the wrong values. So I'll check the unit circle first, and then part 2 will be, you have the unit circle completed for you, can you use it? So it'll be 2 parts. So now that I have the unit circle completed, here's how I use it. So sine of 150. Well, in terms of what I know that these go up by 90. So like this is 90 and then plus another 90. This is 180 plus another 90, 270, 360. So I know that 150 falls somewhere between 90 and 180. So this is a quadrant 2 angle. And all students, this is an S quadrant, meaning that sine is positive, cosine is negative, tangent is negative. Well, I'm evaluating sine. So in this quadrant, sine of theta is positive. What that means is my final answer is going to be positive, right? My final answer is going to be positive. It's either going to be 1/2 root 3 over 2 or root 2 over 2. I need to figure out which one it is. Okay, it's going to be positive at the end though because this is a quadrant 2 angle. The next thing I need to do is find the reference angle. So if you do that based on the picture, you can make the reference triangle. And what you were looking for is the red. And this green is the 150. So together, the red and the green make a 180-degree angle. Another way to do that is quadrant 2 has a rule. The quadrant 2 rule is that R plus S equals 180. 150 is an angle bigger than 90, so it's an S. Reference angles are always acute angles. They're little angles. So since 150 is a big angle, it's S. So I'm going to plug 150 in here, and I can solve this way too by subtracting 150. So either way, from the picture or from the rule, I get that the reference angle is 30, which means when I solve this, I want to refer to the 30-degree angle. All right? So if I'm referring to the 30-degree angle, the coordinate point at the 30-degree angle is this. And I'm working with sine. So yesterday we talked about cosine is going to be your x values and sine is going to be your y values. So I'm going to focus in on this one. So what the reference angle tells me is that the sine of 30 degrees is 1/2. So I know that the sine of 150 degrees is also going to be 1/2. Sometimes I'll add a negative to that and sometimes I won't. In this case, I'm not going to add a negative to it because I know that this is in quadrant 2 and sine ultimately is positive in quadrant 2. So this is my final answer, 1/2. Anybody have questions on that one? All right, the next one, cosine of 240. Well, in terms of a picture here, I know that 240 is somewhere between 180 and 270. So 240 is falling somewhere in quadrant 3. And this is all students take. This is the T quadrant. So tangent's positive down here, but sine and cosine are negative. So that means that my answer, cosine theta, in this quadrant is going to be negative. So whatever I get at the end, I'm going to add a negative sign to it. Now I need to get my reference angle. You could make a reference triangle and solve it this way. So this is like 180 degrees plus the reference angle equals the red angle, or you can use the rule. The rule in quadrant 3 is that reference plus 180 equals standard. Reference angles are small angles, standard angles are big angles. So 240 is a big angle. So I'm going to put it in for S. And I can solve by subtracting 180. Just keep in mind you don't have a calculator, so you're doing this by hand. 0 minus 0 is 0. I can't do 4 minus 8, so I'm doing 14 minus 8 instead. So my reference angle is 60 degrees. What that means is I'm going to use the coordinate point at 60 degrees. And since this question is asking me for cosine, cosine is x, so I want to use the x value. So what this tells me is that the cosine at 60 degrees is 1/2. And since 240 is the standard and reference angle, the cosine of 240 is also going to be 1/2. But because I said cosine's negative in quadrant 3, I'm going to add a negative to this. So the cosine of 240 is actually negative 1/2. The cosine of 240 is the same value as the cosine of 60. The triangle is the same triangle, but based on its directions, its x value is negative because it's on the left-hand side. So I'm adding a negative to my answer. Questions on either of them? Now, the next one I told you to skip. It's also a typo, because even if you tried to do it, it wouldn't work out. It should be 225. So just change it to 225 on your paper. And so cosecant is not a function that I know, but I'm just going to focus on the angle itself. 225. So 225 degrees is somewhere between 180 and 270. So I'm looking at another quadrant 3. And cosecant goes hand in hand with sine. So what I'm really thinking about is, what do I know about sine in quadrant 3? This is all students take. This is my T quadrant. So tangent's positive, sine is negative. So my final answer is ultimately going to have a negative with it. All right, I need to find the reference angle. So you could create this triangle. You're trying to find this, but you know this and that. So this is 180, and this is my reference. So, or you can use the picture, or you can use the rule. In quadrant 3, the rule is that my reference angle plus 180 equals my standard angle. Standard angles are big, reference angles are small. So reference plus 180 equals this big angle, which is a typo, it's 225. If you use 215, you're not going to get an angle we know, right? I need it to equal 30, 60, or 45, because I need to be able to use those three things. So I'm going to subtract 180. 5 minus 0 is 5. I can't do 2 minus 8, but I can do 12 minus 8. So my reference angle is 45 degrees. So that tells me I'm going to head to the 45-degree angle, and the coordinate there is this. Cosecant pairs with sine. So I want to find the sine at this point, and sine is the y value. So the sine of 45 is root 2 over 2, which means the sine of 215 is also root 2 over 2, but because 215 is in quadrant 3, I'll add a negative to that. That we were able to do from like yesterday's stuff. But the question doesn't say what's the sine of 215. It says what's the cosecant of 215. So what do I have to do to that fraction? What do we do to get from sine to cosecant? We just flip it. So all I have to do is flip this fraction. So it's negative. You can't really see my negative. There is a negative right here. So it's negative 2 over root 2, which I don't have space to I can do it over here. So if I rationalize that, I end up with negative 2 root 2 over 2. And the 2's cancel out. So the cosecant of 215 equals negative root 2. I'm working through it like a sine. I'm working through it exactly like I worked through number 1. And I'm going to get the final answer for my sine. And then all I'm doing at the end is flipping the fraction because it's a reciprocal function. Obviously, that's a lot more work. You can see it on the board. The next group is in radians, which I think this is the only point in the unit where radians is the easier of the methods, because I don't have to do any work for the reference angle. I just have to look at the fraction. So first things first, I want to pick my quadrant. I have to think about 5/4, but I have to think about it without a calculator, right? 5/4 is like 1 and 1/4. And that's like 1.25. So this is 1 and this is 1.5. So this is somewhere in quadrant 3. And this is my tangent quadrant. So that means cosine's going to be negative. My final answer should have a negative with it based on quadrant 3. We okay with that part? Now the next thing I would need to do is find my reference angle. Normally we would draw the triangle and find it, but I don't have to do that for this problem. Because the angle itself has a denominator of 4, the reference angle is going to have a denominator of 4 too. No matter what I add or subtract to it, it's going to have a denominator of 4. So the only possibility of a reference angle would be pi over 4. I don't have to do any work for that. The denominator is 4, so the reference angle has a denominator of 4. So the cosine of pi over 4 is the x value at pi over 4, which is root 2 over 2. And the cosine of 5 pi over 4 is the same thing, except because this angle is not in quadrant 1, where everything's positive, this one's in quadrant 3, where x values are negative and cosine is x values. So I add a negative to it. So cosine of 5 pi over 4 is negative root 2 over 2. Sine of 2/3, well, I have to think about what 2/3 is. If you don't know that 2/3 is 0.67, you should at least know what 1/2 is, right? So if I'm looking at a denominator of 3, 1/2 would be 1.5 over 3, right? That's half of 3. That's bigger than 1.5, or sorry, 0.5. So it's bigger than 1/2, but it's also not bigger than 1, because 2 pi over 3 is less than a whole. So this falls somewhere in quadrant 2. And what I know about sine in quadrant 2, in all students take Calc, sine is positive in quadrant 2. So my final answer for this one is going to be a positive number. I already know what the reference angle is because the denominator is 3, so the only possible reference angle would be pi over 3. So I just have to find the sine at that angle. So I go to pi over 3, and I look at the y value, because sine is y. And the sine of 2 pi over 3 is the same thing. Sometimes I'd have to add a negative to my answer, but in this case, because I'm in quadrant 2, I don't have to add a negative. Sine's positive in quadrant 2. The triangle for this is the same as the triangle for this. And they're both above the x-axis, which puts them in a positive y space, so these both stay positive. For the last one, I'm thinking about the fraction 11/6. Well, that's 1 and 5/6, which is more than 1 1/2, because 1 1/2 would be 1 and 3/6. So this is bigger than 1 1/2, but it's less than 2. So this is somewhere in quadrant 4. And what I know about quadrant 4 is that secant pairs with cosine, and in quadrant 4, all students take calc, cosine is positive. So my final answer is going to be positive. My reference angle is pi over 6, because the denominator is 6. So the cosine of pi over 6 is the x value at pi over 6, which is root 3 over 2. And the cosine at 11 pi over 6 is the same thing. Sometimes I would add a negative to that, but in this case I'm not going to add a negative because I'm in quadrant 4. But I want the secant. So to get the secant, the only thing I have to do to this is to flip the fraction at 11 pi over 6. So I'll flip this to make it 2 over root 3. And then rationalize it. So 2 root 3 over 3 is the final answer for that one. Today we're going to do the opposite. So for all of these, I gave you S. I gave you the big angle, and I wanted you to find the small angle. All right? Today, I'm not going to give you an angle at all. I'm going to give you the coordinate point. So I'm going to say, okay, the answer is 1/2. What possible angles could be at 1/2? So you'll find the reference angle by going to quadrant 1 and looking for the 1/2, and then you'll apply that to 2 quadrants. So on your quiz that you took the other day, this is like the second section where there was 2 answers for all the problems. The ones you're about to do now have 2 answers, all right? So we are going to learn how to solve linear trig on page 7 of your toolkit. I have the steps kind of typed out here. You don't have those steps on your toolkit. I'm just having them up there so you can refer to it if I lose you in any. First thing we have to do is we have to pay attention to the directions. The directions say from 0 to 360. Now on the quiz that you took, when did we take the quiz? Last week? No? Did we take it this week? No. On the quiz that you took this week, when the direction said 0 to 360, you had to make sure that you hit the degree button on your calculator. And when it said 0 to 2 pi, you had to make sure you hit the radian mode on the calculator. You don't have a calculator. 0 to 360 is telling you you want to focus on the 30, the 45, and the 60. 0 to 2 pi saying you want to focus on the pi over 6, pi over 4, pi over 3. Right, so it's a matter of like which of the angles you're looking at. They're the same angle, they're just in different forms. So 0 to 360 means my answers are going to be in degrees. My reference angles are going to be either 30, 45, or 60. Those are the 3 we know. All right? So this one's already solved. The first step says get the trig function alone. So if you peek ahead, you can see, like, I'm eventually going to have to do some math to get the trig function alone. All of the math is really basic. You don't have a calculator. All right? So get the trig function alone. In number 41, that's already done for me. The next thing I have to do is find the reference angle. When you had a calculator, you did the sine inverse. It's in your toolkit. When you had a calculator, you did the sine inverse of root 2 over 2 and you got a decimal, right? When you got a number. You don't have your calculator, right? You have a unit circle. So hopefully you have a completed one in front of you. Here's what we're gonna do to find the reference angle. We're gonna look for where is, so sine is y. So I'm gonna look for where is y equal to root 2 over 2. I'm not paying attention to the negative because I'm not gonna find any negatives on my unit circle. Everything you have written on your unit circle is positive. So I just have to look for the value. So you're looking at your completed unit circle. Hopefully the one that you did for the warm-up is right there. And you're looking for where is y root 2 over 2. What degree value does y have root 2 over 2? 45. So the reference angle is 45 degrees. If we had a calculator and we did sine inverse of root 2 over 2, it would be 45. We don't have a calculator, so we got to use the quadrant one. Everybody okay with that so far? All right, so the reference angle is 45 degrees. We're going to use all students take calculus to pick our quadrants. Here's the thing, sine is negative root 2 over 2. So if I'm using this, I want to pick the quadrants where sine is negative because my problem has a negative number in it. So I know that sine is positive here and here, which means my answer is going to be somewhere here or here. Everybody okay with how we pick those quadrants? I'm referring, if that was positive, I'd pick 1 and 2. So it depends on when you get the trig function alone, do you have a positive or negative number? Okay, so because I'm going to do 2 and 3, I'm going to have 2 answers, a 2 answer and a 3 answer. For some of you, you're going to draw a picture in quadrant 2 and you visually work on finding the angle. For some of you, you just know the rule. I'll show both, just know you don't have to do both, all right? So if I am drawing an angle in quadrant 2, and then my reference triangle is with the x-axis, I know the reference angle. I know this angle right here that I'm coloring in red is 45. But what I want is this angle. So the green angle, I don't know. The red angle is 45. That's my reference angle. Together they make up a half circle, right? So the rule in quadrant 2 is that the reference plus the standard make a half circle. I know that the reference angle is 45. So the math that I'm going to do for quadrant 2 is I'm going to subtract 45 here. But remember, you don't have a calculator, so you just have to do that math by yourself, all right? Big math. I'm going to borrow from this 8 and do 10 minus 5, and then 7 minus 4, and then 1 minus 0. This is 135 degrees. That's my first answer. That's my quadrant 2 answer. In quadrant 3, I can draw the reference triangle, and you don't have to draw the triangle. You just can. I want this angle, but I have this one. Sorry, I have the red angle, but I want the pink angle. The red angle is 45 degrees. That's the reference angle. That's the little angle. Remember, there's a reference angle and a standard angle. Reference angles are the small ones. Standard angles are the big ones. That pink angle is big. I don't know what that is. What I know is that my red angle plus 180, so plus this half circle, equals the big angle altogether. You can memorize the rule or you can draw the picture, right? I know that the reference angle is 45, so I'm going to do 45 plus 180 to get my answer. So 45 plus 180, 180 plus 20 is 200, plus another 25 is 225. So sine is positive in 1 and 2, right? But I have a negative sign with this. So sine is negative in 3 and 4.
But you did quadrant 2.
Oh, why did I do quadrant 2? Were you guys all confused and just let me go up here?
Yeah.
All right, thank you. All right, let's not do quadrant 2. I circled 3 and 4. All right, over here, quadrant 4. Okay, so we can draw a picture in quadrant 4. So there's 45, and we want that one, right? So together, it's a full circle. So R plus S equals 360. And R is the small angle, which is 45. So the math that I'm going to do is 360 minus 45. 5 minus 4 is 1. 3 minus 0. 315 degrees. Sorry about that. I wrote 3 and 4, but I did 2 and 3. Did I lose any of you there since I did the wrong quadrant? Hopefully not. All right, just in case, let's try it again. All right, so the first thing I have to do is I've got to get the trig function by itself. Now, in this case, it's not alone. See how there's a 10 in the front? So I'm going to divide out the 10. And 5/10 is the same thing as 1/2. When you do this, your outcome is only going to be one of 3 things. It's either a 1/2, a root 2 over 2, or a root 3 over 2, right? Those are the only things we know with the circle. So it's got to work out to be one of those. So cosine is 1/2. That number is positive. Right? It's a positive 1/2. So when I'm thinking about this, which 2 quadrants is cosine positive it? So my answers have got to be 1 and 4. What I need is a reference angle. So to get the reference angle, and because it's cosine, I want to know where is x 1/2. If it was sine, I'd say where is y 1/2. So it just depends on the trig function. All right, so where is x 1/2? You guys have a unit circle in front of you. Look at your coordinate points. What degree is x 1/2 at? 60. So my reference angle is 60 degrees. And I'm going to use that angle in 2 quadrants. Quadrant 1 and quadrant 4. Quadrant 1 is easy. The reference angle is the same as the standard angle. So my quadrant 1 answer is also 60 degrees. My quadrant 4 answer, we have this angle, that's 60. We want this angle, which completes the full circle. So the quadrant 4 rule is that the reference plus the standard equals a full circle. We have the small angle. We have an acute angle. We have the reference angle. So if I subtract 60, I get 300 degrees. So my second answer is 300 degrees. The only thing that is different from what you did on your quiz is the reference angle step. On your quiz, you used an inverse button in your calculator. Here, you're using the unit circle. Everything else is what we did on the quiz. So I'm going to have you guys try 43. So see what you can do. Maybe you already worked ahead, maybe you didn't. But see, now that you've seen 2 of them, see if you can apply that and do 43. I got 60 because it's cosine, and cosine's x, sine's y. So I wanted to know where is x 1/2. So I looked on a completed unit circle, and there's coordinate points. There's 3 different coordinate points. Which coordinate point has an x value of 1/2? 60 degrees. So you have to look at the circle for it. What's the reference angle? Where is x root 3 over 2? 30. All right, the reference angle is 30 degrees. Does anybody need me to explain that one? Where the 30 is coming from? All right, what quadrants do I want to apply this to? It's negative root 3 over 2. Aiden?
2 and 3.
I'm going to use 2 and 3. And you can draw the picture or you cannot draw the picture. That's up to you. But the relationship here is that the R and the S equal 180. And I have the R. So ultimately I end up doing 180 minus 30. So the first answer is 150 degrees. And in quadrant 3, you can draw the picture or not, but the rule is that the reference angle plus 180 equals the standard. And so I have the 30 plus the 180. So this answer is 210. What do we think? All right, all of those were from 0 to 360. Now the next examples that we'll do will be from 0 to 2 pi. That doesn't change the process. It changes the angle you're picking, right? Instead of picking 30 degrees, you'll pick pi over 6. Instead of picking 45 degrees, you'll pick pi over 4. Now that does make the math more complicated because you're going to be adding and subtracting fractions without a calculator.
Question on this test next Monday, right?
Uh-huh.
Are we only using
It's not till next Thursday.
Oh, next Thursday, no, the test. Is it only like the only part of the new circle we learned so far, right?
That's it. Just quadrant 1. That's it. Now one thing we didn't do, does anybody notice anything that is missing? All of these examples have been sine and cosine. Have you seen a tangent yet? Tangent's complicated because if sine is x, if cosine is x and sine is y, that doesn't leave anything for tangent. Tangent is y divided by x. So you're going to be dividing fractions to find tangent. Now I'm going to show you how to do that. What are you going to do? You're going to memorize the tangents because you're not going to want to work through them. So you're going to have to memorize 3 tangents too, but we're not going to do those yet. I want to make sure you're really good at this before I complicate it at all. So that's why it's not till next Thursday. At some point you got to do the tangents, all right? Now, the next part, like I said, is not any different. However, you are eventually going to have to solve quadrant 2, 3, and 4 using rules. And those rules are going to involve adding and subtracting fractions. And if you don't have a calculator, then you have to find common denominators, right? So some elementary math here, but we are going to have to bring it back because we don't have calculators, all right? So again, the first step is get the trig function alone. In example 44, it's already alone. I just need to find the reference angle. Just keep in mind that when I pick the reference angle, I'm not picking 30, 45, or 60 because the directions say we want to use the pi angles. All right, so let's see something. We've got a negative here. So eventually that negative is telling me that I'm going to apply my answers to where cosine is negative. Well, cosine is positive in 1 and 4. So it's negative in 2 and 3. So eventually I'm going to use 2 and 3 rules. And that's because of that negative sign. Now I need to find the reference angle. The reference angle is going to happen at an x value because cosine is x. And I can't include the negative because what I have is all positive numbers. So I'm just focusing on the value itself. Where is cosine root 2 over 2? Where is x root 2 over 2? Well, that's 45 degrees, but we're working with radians. So my reference angle is pi over 4. I'm not using 45 degrees. Tell me if that makes sense. We're okay with that part? All right, and we said we're going to apply that to 2 and 3. Cosine's negative, so we're going to use 2 and 3. Now feel free to use your space to draw a quadrant 2 picture and work your way through it. I'm not going to use the space to do that. We've done enough pictures. The quadrant 2 rule is that in quadrant 2, my 2 angles add together to 180. But now I'm not in degree mode. So I'm going to change the 180 2 pi. The two angles have to add together to pi. I have the reference angle, so I'm going to replace the r with pi over 4. So if I want to get s alone, what do I have to do? Subtract pi over 4, right? So that s is alone on this side. So I'm ultimately looking to do pi minus pi over 4. You can't subtract fractions that don't have common denominators. What does this denominator need to be? If I put a 4 on the bottom, I just have to make sure I put a 4 on the top too. It's as simple as that, right? If you're going to add a 4 to the bottom to make a common denominator, add a 4 to the top too. 4 pi over 4 is just pi. The 4s would cancel out. So now I can do the subtraction. The way that we subtract fractions, we do 4 minus 1, and we'll just keep the pi. 4 minus 1 is 3 pi. And then when you subtract fractions, the denominator stays the same. This angle is 3 pi over 4. I'm subtracting fractions without a calculator. We need a common denominator. The quadrant 3 rule is that r plus 180 equals s, but now that I'm in radian mode, that's r plus pi equals s. And I know what r is. I said that my reference angle is pi over 4. In order to add fractions, you need common denominators. So I need this denominator to be 4. And if I'm going to put a 4 in the denominator, I need to make sure I put a 4 in the numerator too. And then I'm just adding. 1 plus 4 is 5 pi. And then we keep the denominator the same. So it's 5 pi equals 4. Taking the quadrants is the same. Finding the reference angle is the same. The rules are the same, but we're doing it with pi, and that makes it a little trickier. All right, let's try the next one. I'm going to try to skip some steps here for space. But like the first thing I would do is subtract 5. 8 minus 5 is 3. And then I would divide 6. 3 over 6 is 1/2. So I'm just going to skip right to the step where I have sine of theta equals, and it's positive because that's a positive 1/2. And so because this is positive, which two quadrants would I pick? S and A, right? This is sine. Where is sine positive? Because this is a positive 1/2. It's positive in 1 and 2. So eventually I'm going to use 1 and 2 for my work. So my reference angle is going to happen on my unit circle where y, because sine is y, is 1/2. So look at your unit circle and look at the coordinate points. The y value is the second coordinate point. That happens at 30 degrees. But in radians, that's pi over 6. Are we okay with that? So my reference angle here would be pi over 6. Does anybody have questions on where the pi over 6 is coming from? I'm looking at the coordinate points, and the first coordinate point is root 3 over 2, 1/2. The y value is 1/2, and sine is 1/2. So that's the point where y is 1/2. Pi over 6 is that angle. And I want to apply this to quadrant 1 and 2. Well, quadrant 1 is easy. The reference and the standard are the same. So if the reference angle is pi over 6, the standard angle is pi over 6. So the first answer is pi over 6. In quadrant 2, the two angles together equal 180. It's a half circle. 180 is the same thing as pi. And I know the reference I don't know the standard. So if I were to work my way through this math, I'd move the pi over 6 to the other side, and I would do pi minus pi over 6. But I need a common denominator here. So this has an over 6, so this needs to have an over 6. But if I put a 6 in the bottom, I have to put a 6 in the top too. So subtracting straight across, 6 minus 1 is 5 pi over 6. That's my second answer. I want to do the last one with you only because we did not do a quadrant 4 one, and the math is a little different for quadrant 4 because it's 2 pi. So I'm just going to quickly kind of go through this one with you. If I moved this over, I would have a negative number, and sign is negative in 3 and 4. Right, because of that negative in the bottom. Sign's positive in 1 and 2, it's negative in 3 and 4. My reference angle is going to be where the y value equals root 3 over 2. And that's at pi over 3. Like if you look at your coordinate points, the y value is root 3 over 2 at pi over 3. You okay with that? Now applying it to quadrant 4 is the part that's new. So I'll go through quadrant 3 pretty quickly. Quadrant 3, it's r plus 180, which is pi, is s. So I'm doing pi over 3 plus pi. And I'm going to create common denominator. So I'll give this a 3 and this a 3. So ultimately it becomes 1 plus 3. So 4 pi over 3. That one's pretty, we've done a few like that. This one's a little different. The rule is r plus s equals a full circle. But 360 is 2 pi, not pi. So I have this. Ultimately, what I'm going to do is subtract the pi over 3 over. So it's 2 pi minus pi over 3. When I go to give this denominator a 3, I have to give this numerator a 3. So what's the numerator? 32? No, it's 3 times 2. This becomes a 6 pi. Before, it's just 1, so bringing that number up to the top doesn't really change much. But bringing a 3 to the top is going to make that a 6. So it really becomes 6 minus 1. Does that make sense? So 6 minus 1 is 5 pi over 3. So what I'm going to do, I'm going to give you like an exit slip. See where you're at. And then tomorrow, I want to give us time to practice if we need it. Maybe some of you need that, and then some of you don't. So just to kind of check in a little bit more with you instead of waiting until the quiz and seeing that you didn't know what you were doing. So it's a quick check-in. You guys have to leave, that's fine. We'll just figure out where you are tomorrow, okay? Technical lesson. It's only 2 questions. One is in degree, one is in radian. That is not it. Did I give you one or is it? It's like I cut my lesson off. If you don't know, there's no shame in writing, I don't know. That's fine too. Okay? You have to go somewhere.
I studied it.
Yep.